Hello everybody, welcome to Bio 10, Week 2, Lecture 1. My name is Amrita Sharma. We will be talking about the chemistry of life, which will give you a little bit of crash course on chemistry in this class. So let's dive in. What is matter? Anything that occupies space and has mass is called matter. For example, solid, liquids, gases, plasma, anything that you see around yourself is matter. All the living organisms and non-living things are made up of matter. For example, you have table, chair, human beings, buildings, water, anything that is surrounding you that occupies space has mass is called matter. Element is the building block of these matters. For example, here is the list of all the elements put in a periodic table. You have hydrogen, you have helium, you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and sodium, magnesium. All these elements make the building blocks of everything that you see around yourself, the matter. For example, the table is made up of wood. The wood comes from tree. The tree is made up of plant cells. Plant cells, if you have a broad overview, then plant cells are made up of cell wall. Cell wall is made up of cellulose. The plasma membrane is made up of phospholipids. The cytoplasm has carbohydrates, lipids, proteins, and in your nucleus you have nucleic acid. So you know that everything around you is made up of molecules, and molecules are made up of elements. The most important elements of life are carbon, hydrogen, nitrogen, and oxygen. You also have a lot of phosphorus, calcium, magnesium, sodium, sulfur in your body, and you have traces of other elements like zinc or chromium in your body. So the elements are placed in periods in the periodic table. These are essentially metals. These are non-metals. These are transition metals. And the placing of these elements in the periodic table gives them certain characteristic which makes their easy study, and you will also learn a lot about what are the characteristic features of these elements and how they interact with each other in this class. So let's have an overview. Here you see an organism which is a human being. This human being is made up of different organ systems. Here you're looking at the digestive system. Digestive system has organs. Here you're looking at stomach, which is one of the most important organs of digestive system. They have tissues, for example, the epithelial lining of stomach. Tissues are made up of cells. Cells are made up of organelles. Organelles are made up of macromolecules, and macromolecules are made up of smaller molecules. These molecules are formed by the atoms coming together, making a bond with each other. So what is an atom? Atom is the smallest unit of element. They have subatomic particles, neutron, proton, and electrons. So let's see where they are. This is the example of helium atom. Here you see that positively charged particles and negatively charged particles are present. Positive particles are protons. You also have neutrons, which are neutral, and electrons are revolving around the nucleus, which houses protons and neutrons. The atomic symbols represent different atoms. For example, H for hydrogen, O for oxygen, Na for sodium, and Cl for chloride. In the periodic table, you will have this information where you see the symbol of an element, its name, atomic number and atomic mass. Atomic number is nothing but the number of protons, and atomic mass is nothing but the number of protons and neutrons combined. So number of protons is the characteristic of the atomic number, and atomic number is the characteristic of an element. If you know there is one proton, that will always means hydrogen. So here in all three situations you have one proton, but then you have different neutrons. For example, no neutron here, one here, two here. That means these three different atoms of hydrogen will have different atomic mass. So in that situation, atoms tend to have radioactive properties, and these properties are used by scientists for different kinds of applications and listed here. What is the arrangement of electrons in atom? Electrons revolve around the nucleus of an atom. They are filled in the shells in the pattern of 2, 8, 18, 32, which means in the first shell there are 2 electrons, in the next shell there are 8, then 18, 32. But for today's discussion, we will only need to know about the first 2 shells. Atoms have a tendency of completing their outermost shell. If they have less than 8 electrons in their outermost shell, they will either like to give away or take some electrons so that their outermost shell has complete 8 electrons. How many number of electrons are present in the outer shell determines the valency of an atom. Let me give you an example of carbon, nitrogen, oxygen. In first shell, all these will have 2 electrons. But in second shell, carbon has 4, nitrogen has 5, oxygen has 6. Because carbon needs 4 electrons, nitrogen needs 3 electrons, and oxygen needs 2 electrons to make a complete outermost shell with 8 electrons. The valency of carbon is 4, nitrogen is 3, and oxygen is 2. So we have had an overview of matter and atom. Now we will see what are molecules. So atoms come together to make chemical bonds to form molecules. The first type of chemical bonding is called covalent bonding, in which the atoms share their valence electrons. First example is non-polar covalent bond. The non-polar covalent bond occurs between the same kind of atoms. Here you have the example of nitrogen. As we saw before, nitrogen has 2 electrons in its first shell, and in second shell it has, look at these X, 1, 2, 3, 4, 5. It has 5 electrons in outermost shell and it needs 8. So how many will it borrow from the other one? 3 electrons. So it takes 3 from the other one, and how many will be there? 1, 2, 3, 4, 5, 6, 7, 8. So both these atoms will end up having 8 electrons in their outermost shell after sharing 3 electrons with each other. But since both the participants are same, they will make a non-polar covalent bond. A polar covalent bond is, for example, water. Here you have oxygen, which has 2 electrons in the first shell. In second, it has 1, 2, 3, 4, 5, 6. To complete its outermost shell, it needs 2 electrons. It will share one with this hydrogen and share other with this hydrogen. So hydrogen will end up having 2, 1, 2 these, and oxygen will end up having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So the outer shell of both the atoms is completed. But since oxygen has a tendency of pulling these electrons towards itself because it has bigger nucleus. It will have slightly negative charge on itself. These hydrogens will end up having slight positive charge on themselves. That is why you have a separation of charge. This side is positive, this side is negative in this molecule, which is why it is called a polar molecule. A polar molecule has a better tendency of dissolving in water. The other kind of chemical bond is the ionic bond. Ionic bond example is sodium chloride, in which the participating elements are sodium and chloride. So here you see that sodium has 1 electron and chloride has 7 electrons in its outermost shell. Instead of this one trying to get 7 electrons, which will make this atom very unstable, it will just donate its electron completely to chlorine. The outer shell of sodium will also be complete. The outer shell of chlorine will also be complete just by completely giving away the electron. So in this process, sodium becomes positively charged, chlorine, which now becomes chloride, becomes negatively charged. This periodic table gives you an idea that the elements on this side has better chances of giving away their electrons, and the elements on this side have better chances of taking up electrons from the other elements. Some properties of ionic compounds are that they are usually solid, they can ionize when they are in water, and they have different functions in the biological system. For example, sodium and potassium gives you the electron gradient in your neurons. Let's look at the hydrogen bonding now. You have already seen how the molecule of water looks like. It has a little bit of charge separation where your hydrogens are slightly positively charged and oxygen is slightly negatively charged. So when there is a charge separation, this end being positive, this end being negative, there will be an attraction between this negative and this positive. So this attraction between hydrogen and the other negatively charged species in that molecule forms the hydrogen bond. Hydrogen bond is usually indicated with dots. It's not as strong as covalent bond because covalent bond is the real sharing of electrons, whereas hydrogen bond is just an attraction between negative and positive ends of a molecule. So this hydrogen bonding, or the attraction between the molecules of water within itself, gives interesting property to water molecules. Van der Waals forces are also similar to hydrogen bonding. In this also, when a molecule has a charge separation or an atom has charge separation where one end is positive and the other end is negative, you will have some attraction with your neighbors. These atoms will have some attraction because there is nature's phenomena where you know that negative and positive charges attract each other. These van der Waals forces are much weaker and they are characteristically similar to hydrogen bonding. It's just that in hydrogen bonding, one of the participants have to be hydrogen. In this, it can be anything. So here are some more properties of covalent bonds which you can read. Now let's look at some properties of water. We have seen that oxygen, which has 6 electrons in outermost shell, shares 1 electron each with hydrogen because the nucleus of oxygen is bigger than the nucleus of hydrogen, it pulls the electrons towards itself and has delta negative charge, and hydrogen has delta positive charge. This makes this molecule polar. So, the polarity of water gives it interesting properties. There are polar substances, as we talked before. Polar substances will have better tendency of dissolving in water. That is why they are called hydrophilic. And non-polar substances has lesser tendency of dissolving in water. That's why they are called hydrophobic. Example is oils and fats. Water has very interesting properties because of also the hydrogen bond present in them. Water can regulate temperature. It needs some energy to break the hydrogen bonds, which is why it is liquid at room temperature. You have to heat it up to make it convert into vapors. Now look here. When you have high temperature, molecules are randomly moving and they have a chances of tighter packing. But as the temperature goes down and water cools down, they have to have a specific hydrogen bonding, which gives them a lattice-like structure with lot of empty spaces in between. Now this is ice. So because of these empty spaces between the molecules, ice is lighter than water, which is why ice is able to float on the surface of water. This floating ice over the lakes or seas give an opportunity for aquatic animals to protect themselves from very cold weather outside. Now we have heard many a times that water is universal solvent. What gives water that property? It's the polar nature of water molecule. Let's say you have sodium chloride in your kitchen, which is NaCl. When sodium chloride dissolves in water, it breaks into sodium positive and chloride negative. Water is able to make these hydration shells around these ions. Because of these hydration shells, this sodium cannot come close to chlorine, which is why the salt remains dissolved in water and does not precipitate out. We have already talked about the term hydrophilic and hydrophobic. The polar substances have the tendency of staying dissolved in water. They like water because water is also polar. Because of that positive negative charge attraction, they are called hydrophilic. Whereas hydrophobic molecule would be something which is non-polar. It does not have positive negative charge on it, which is why it doesn't get attracted to the water molecules and doesn't really like water molecules, which is why they are called hydrophobic. Water can form ions, the hydroxide ion or hydroxyl ion and hydrogen ion. How? So H2O is HOH. Here you're sharing an electron pair and here also you're sharing an electron pair. But as we know that oxygen has bigger nucleus, it will attract this electron pair and get out as OH negative because it has taken this extra electron with it. Hydrogen with this hydrogen that has lost the electron will become H positive. In pure water, how many H positive ion do you have? It is 10 to the power minus 7 molar concentration. So any liquid that has 10 to the power minus 7 molar concentration of H positive ion will be considered neutral in their pH. What are acids? Acids are those molecules which donate a lot of H positive ion. and bases are the molecules which releases a lot of OH negative ion. For example, look at this table. HCl, H3PO4, phosphoric acid, nitric acid, sulfuric acid, carbonic acid. They can all donate these hydrogens when they are dissolved in water, which is why they are acids. Whereas base, the sodium hydroxide, potassium hydroxide, calcium hydroxide, or ammonium hydroxide have the tendency of giving these hydroxyl ion or the hydroxide ion when dissolved in water. That is why they are bases. So let's have an idea of what pH is and what buffers are. pH is nothing but the hydrogen ion concentration. If the hydrogen ion concentration is, for example, 10 to the minus 7 here, then negative log to the base 10 would be just 7. So 7 is your pH. If the concentration of hydrogen ion is 10 to the minus 5, then the negative log to the base 10 would be 5. So pH would be 5. As we have mentioned before, that 7 is a neutral pH. Anything lower than that would be acidic. Anything higher than that would be basic. Buffer is a system of molecules in which the ions are produced in such a way that the pH does not change a lot. In your body, the blood system is a very good example of buffer. So blood has a pH of 7.5. This is the pH that it needs for its proper functioning. In your blood, there is carbonic acid. Whenever the pH is low, the carbonic acid breaks and produces H positive ion. But when the pH is high, it becomes the carbonic acid again, consuming these H positive ion which are in solution. Thus, it maintains the pH of blood. If there is a lot of H positive ion, that means the pH falls, then the blood has more acid in it, and the situation is called acidosis. And the reverse situation, where you have a higher pH, then the situation will be called alkalosis. And both these situations are not very healthy for normal functioning of body. Two most important organs for maintaining this pH are lungs, because lungs inhale carbon dioxide from outside, which is required for making this carbonic acid, and kidney, which filter out the bicarbonate, which again maintains the carbonic ion concentration in the blood. So the summary is, we have learned about matter, the components of matter, which are atom and molecules, and we have looked at the inorganic molecules of life, which is water, acids, and bases. Now we will look at the organic molecules of life, which are also called the biomolecules, in the next lecture. Thank you for tuning in.